Welcome to the deep dive. Today we're diving into a really crucial area, especially if you're gearing up for a senior software engineer interview, how microservices actually talk to each other.
Yeah, it's a big one.
You're facing that technical chat, and suddenly there's this huge list of options: SAP, XML-RPC, REST, gRPC, message brokers. It can feel overwhelming.
It absolutely can. And I think the key thing, especially in interviews, isn't just, rattling off technology names. Interviewers want to see if you understand the principles behind choosing them. Can you think critically?
Exactly. So our mission today isn't just to list things. We want to distill the key considerations, give you something actionable for those technical discussions. It's about focusing on why you'd choose something, not just what it is.
Right. And the very first step really is deciding on the style of communication needed. Is it like blocking synchronous?
Yeah.
One service calls another and just waits.
Yeah, waits right there for the answer.
Or is it more non-blocking, asynchronous, maybe event-driven,
Yeah.
sort of send and maybe get a reply later kind of thing?
Right. Like, do you need that immediate give me the user profile now interaction, which is request response? Or is it more like an order-placed event that other services might react to later?
Precisely. Getting that high-level style nailed down, synchronous versus asynchronous, request response versus event-driven, it seriously narrows down your technology choices right from the start. It's like setting the compass.
Okay, makes sense. So once you have a feel for the style, what are the next big things to weigh up when looking at specific technologies?
Well, a huge one, and one that often trips people up, is backward compatibility.
Ah, yes. The please don't break everything when I deploy this rule. You make a change and suddenly, boom, chaos.
Exactly. And some technologies make this easier than others. You ideally want something where adding, say, a new field to your message doesn't just break all the existing consumers.
So it's about making those non-breaking changes, well, easy, and facilitating that evolution without constant fear.
Right. And crucially, being able to validate that compatibility before you deploy. That's really valuable. Can you check if your change is safe?
Yeah, that proactive validation sounds like a lifesaver, instead of just hoping for the best.
Absolutely. Think about schema evolution strategies with message queues, for instance.
Hmm.
You can often design messages so older consumers can ignore new fields they don't understand. It's about being deliberate.
Okay, backward compatibility, check. What's another core principle to keep in mind for that senior interview?
Explicit interfaces. This is basically the contract your service offers to the outside world. It needs to be crystal clear.
Like a clear menu for what the service offers and how to order it for other teams or even internal teams using it.
Exactly. What data can you get? How do you ask for it? What will the response look like? It sets expectations. Clear expectations mean fewer misunderstandings, easier integration for consumers.
And it helps the team maintaining the service too, right? Stops them from accidentally breaking things.
Definitely. This is where things like schemas are so important. Even if the tech doesn't force you to use a schema, you really should. It's a blueprint. And don't forget good documentation.
Yeah, even with a perfect schema, sometimes you just need plain English explaining what's going on.
Totally. Think of contract testing, too. It actively enforces that the provider and consumer are sticking to that agreed-upon interface.
Makes perfect sense. Clear contracts are key. Okay, let's shift a bit. The tech world changes fast. You mentioned technology agnosticism earlier. Why is that important with microservices?
Well, think about why we use microservices in the first place. A big part of it is flexibility, right? Choosing the best tool for each job.
Right. You don't want to be stuck using, say, only .NET tools if something way better comes along for a specific task.
Exactly. If your communication APIs lock you into one specific stack, you lose that freedom. What if a new language or framework is perfect for a future service? You want the option to use it without a massive rewrite of how services talk to each other.
So keeping the communication layer neutral preserves that core microservice benefit of flexibility and independent evolution.
Precisely. It allows teams to innovate independently. Patterns like an anti-corruption layer can even help bridge the gap between newer agnostic services and older technology-specific systems.
Okay, good point. So we've thought about future-proofing and keeping developers happy. What about the people actually using the service, the consumers?
Ease of use for consumers, super critical. Your service might be brilliant internally, but if it's a nightmare to interact with, what's the point?
Yeah, if it's hard to integrate, teams will just avoid it or waste tons of time slowing everything down.
Definitely. And this often brings up the debate about client libraries. Do you provide one?
I can see the pros and cons. A library makes it easy to start, right? Just plug
It
in.
can, yes.
Yeah.
It lowers the initial barrier,
Yeah.
but it also creates coupling. Now, the consumer depends on your library, which might dictate their language or framework choice. It kind of undermines that technology agnosticism we just talked about.
Right. It's that trade-off again, convenience now versus flexibility later. It sounds like leaning towards giving consumers more freedom is generally better.
Often, yes. Empowering consumers to use their preferred tools usually leads to less friction and wider adoption in the long run.
Okay. Now, something that sounds inherently bad, exposing internal implementation details through your API. Why is that such a no-no?
Well, imagine your API starts revealing things like your internal database table names or specific algorithms.
Uh-oh.
Right, consumers might start relying on those details. Then, what happens when you need to change your database or refactor that algorithm?
You break everyone who was depending on those internal bits you accidentally exposed.
Exactly. The cost of change skyrockets. You become afraid to refactor or improve things internally because of the potential blast radius. That's how technical debt piles up. You want a stable, abstract interface, a facade that hides the messy, changing internals.
Keep the internal complexity hidden, present a clean interface.
Got it. Okay, we've hit the main principles. Let's briefly touch on some of the actual technology someone might hear about. RPC remote procedure calls. What's the gist? The core idea is simple. Call a function on a remote machine, like it's right there in your own code. OCP and gRPC are common examples. They often involve defining a strict contract first.
And then there's REST, probably the most common one people encounter.
Very likely. REST is more of an architectural style. It's built around resources like customers or orders identified by URLs. You use standard HTTP verbs, get, post, put, delete to interact with them. It seems simple, but designing truly RESTful APIs involves more nuance, like using hypermedia controls.
Okay. And GraphQL, that feels newer.
It is newer compared to REST and SOAP. The interesting thing about GraphQL is that the client specifies exactly what data it needs in its query. It can even fetch related data across multiple conceptual resources in one go.
So instead of the server deciding the payload, the client asks for just the bits it requires.
Precisely. This can be really efficient, cutting down on overfetching or underfetching data, which can happen with traditional REST APIs sometimes.
And finally, message brokers. These sound different because they're asynchronous, right? Not that immediate request response.
Exactly.
Yeah.
Things like RabbitMQ or Kafka act as intermediaries. Services send messages to a queue or topic, and other services pick them up when they're ready. It decouples the sender and receiver.
Which is great for event-driven stuff, like
Yeah.
reacting to events without direct dependencies.
Absolutely. It builds resilience. If one service is temporarily down, the messages can often wait in the queue. It supports scalability really well, too.
Wow. Okay. This has
Yeah.
been super helpful. So recapping, for anyone prepping for that senior interview, don't just list tech. Understand the style needed: sync, async, request response, event-driven.
Right, and then evaluate based on those key factors.
Backward compatibility.
Explicit interfaces.
Technology agnosticism.
Ease of use for the consumer.
And crucially, hiding those internal implementation details.
Getting those principles down gives you a solid framework for discussing any communication tech, right? Even new ones.
Exactly. That deeper understanding is what interviewers are looking for. It shows you can think architecturally. So, a final thought for everyone listening. Think about your own experience. Can you recall a project where the communication tech choice really made a big difference, good or bad, to how things evolved or how easy it was to maintain? Mull that over. It could give you some great real-world examples for your interview.
Great point. Real-world context is always powerful.
And with that, thanks for joining us for this deep dive.